Welcome back. We're back into section 5, intervals of increase and decrease. So what we're going to do is we need to find the first derivative critical values. These occur when f prime of x equals 0 or f prime of x is undefined. Those are the only times when we can change from increasing or decreasing. Okay? And that's what we're going to use for our interval chart. So, if f of x equals x over x squared minus 1, you should take the time, pause the video, and convince yourself that the derivative is going to be equal to negative x squared minus 1 over top of x squared minus 1 squared. And in fact, it's going to be most useful if I common factor out the negative in the top and come up with this. Now again, I would stop the video and make sure that you can get that, and because you might be asked for that. Okay, so what I want to do now is determine the critical. We're going to set f prime of x equal to 0, and we're going to get negative x squared plus 1 over x squared minus 1 squared equals 0. Thinking about that old trick that I have, cross multiply, and you're going to come up with negative x squared plus 1 equals 0. So x equals plus or minus 1. Also, we're going to get some points when critical values, when that is true. And they tend to match up with each other, so that's pretty cool. That worked out. So our critical values are which means that when we have our domain, I'm not going to draw the vertical axis, I don't really need it, but there's 0, there's 1, there's negative 1. My intervals that I'm going to be interested in are all x less than negative 1, all x between negative 1, oops. Notice not equal to, because when it's equal to, then the derivative is equal to 0. And I'm interested in all x greater than 1. And what I want to know is whether or not the derivative is going to be positive or negative in those areas. Okay, so that we're going to use that for our interval chart. So our interval chart's going to look like this. Very similar to what you used in grade 12, I believe. It's going to be x is less than negative 1, between negative 1 and 1, x greater than 1. We're interested in the overall sign of the first derivative. Now the overall sign of the first derivative is going to be given by this, and that negative. So as far as I'm concerned, that negative has just as big a role to sit there. So I would sit it there and say it's going to be negative for everyone. It's contributing a negative. The x squared plus 1 portion, if I put in a value less than, well, that's always going to be squared. No matter what I put in for x is going to be squared, is going to be positive. So all of these are positive. And this one, because of that squared, all of these are going to be positive. Overall, this all gives me something to say about the sign of the second derivative. The first derivative. So all of these talk about the sign of the first derivative. So in this case, hey, we're going to be negative, negative, negative. It's kind of weird, but there you go. It doesn't mean it's wrong just because it's odd. And this means this is going to tell me something about f of x. Well, this means that it's going to be decreasing on negative infinity to negative 1. It continues to decrease on negative 1 to 1. And it continues to be decreasing on 1 to infinity. That means that this curve, f of x, is decreasing everywhere. Okay, so it's a completely decreasing graph. Going from left to right, it will be decreasing. Taking a look at this, you got nowhere that we're going to have a max or a minimum because we're not changing from increasing to decreasing. And that's about it. That's what we're going to have. That's kind of interesting. We'll pause there and we'll do intervals of concavity.